Alright, welcome back. Hope you guys had a good spring break. Now, looking at this first problem with nested triangles, and we are using workbook page 212, so you are welcome to take notes on that as well, if you'd prefer. We are looking at a triangle inside another triangle. That's why they're called nested triangles. So what we need to do is identify what trigonometric ratios we need to write, and then write them and solve for the unknown variables, whatever they may be. So first we've got 45. Well, for this triangle, looking at this left-hand triangle, I need to remember SOHCAHTOA. SOHCAHTOA is my friend. And I can say, okay, for 45 I have my opposite side and my adjacent side. I do not have my hypotenuse side. With O and A, that means tangent. So I can write that the tangent of 45 degrees is equal to the opposite over adjacent, which in this case is 5.5 over W. Now, tangent of 45 is very nice. It is 1. That's actually because right here we have a 45, 45, 90 triangle. That means it's also going to be isosceles. So when I multiply both sides by W, I get that W equals 5.5, which is super nice. Now, I know this length right here is 5.5. I don't know x, so now I'm going to turn to my 35 degrees. Well, for 35, I also have opposite. Now I'm looking at this large triangle. I have my opposite side of 5.5. My adjacent side is 5.5 plus x. 5.5 plus x. I want this whole length, this segment plus that segment. So I have tangent of 35, tangent because I have the opposite and the adjacent side, is equal to the opposite side, which is 5.5, all over the adjacent side, which is 5.5 plus x. So now we have to do a little bit more algebraic manipulation. I'm going to write this in parentheses, but you remember when we multiply both sides by 55 plus x to get x in the numerator, we're going to need to distribute the tangent of 35 value to both of those values. So first off, we need to multiply both sides of our equation by 5.5 plus x. And I will also write what the approximation of tangent 35 is, which is 0.7. So tangent of 35 is 0.7, about, when we round it, times 5.5 plus x, and that equals 5.5. We did that by multiplying both sides by this denominator right here. Now I distribute in. And then I had 0.7 times 5.5, which is 3.85 plus 0.7x equals 5.5. All right, we will subtract 3.85 from both sides. And that we will get that 0.7x is equal to 1.65. Now my final step, since 0.7 is multiplied by x, I need to divide both sides by 0.7. And I get that x equals 2.36. That is also rounded. Now let's make sure that makes sense. This is 2.36. Now it makes sense that this is not longer than the 5.5 because 35 degrees is not that far off from 45 degrees. So this is a reasonable value for x. So I just want to make sure to box answers before I go on to number 18. Alright, we tackled that first one. Let's move on to number 18. So number 18, now I've also got nested triangles because I have this triangle inside of this triangle inside of the large triangle. So first, let's find W. Now, W is going to be the opposite side for both 32 and x. Oh, I did forget to write 5. 5 is in the textbook, in the workbook right there, and that's important. So I have my opposite side, and then now we have to think what 5 is. If this is 90, this is 90, and this is across from 90, so that's the hypotenuse. Using my SOHCAHTOA, I know to use sine, since I have opposite and hypotenuse. So sine of 32 is equal to W over 5. Now the sine of 32 is 0.53 approximately. multiply both sides by 5, and then I get 5 times 0.53 is 2.65. W. So first off, we found that this is 2.65. Now we can use this and 6 to find x. Because now I can write that the sine of x equals opposite, which is 2.65, over hypotenuse, which is 6. Now we need to use inverse sine. So I take the inverse sine of both sides, and I get that x is the inverse sine of 2.65 all divided by 6, which is 26.2 degrees. Now if you're having trouble figuring out how to type that into Google, it's the same thing as a sine 2.65 over 6 in degrees. It's important to write in degrees, or they may give it to you in radians, and we don't want that. Alright, so those are 2 example problems. All your homework problems are very similar to these nested triangle